Hi folks, so now that we've talked a bit about selecting and laying out sprinkler heads, we're going to continue the discussion with a little bit more information on zoning, which I touched on in the last lecture, but I want to get through some more formal steps so that you feel comfortable with this part of the design process. So with zoning, there are 3 steps that you're going to go through. And the first of those is to label each of the sprinkler heads that you have placed on your plan with their flow. And we went over this example at the end of the previous lecture, but here it is again. This is the one we've been going through as a class. And each of these sprinkler heads is labeled with the flow. And where did that flow come from? Well, in this case, it would have come from the manufacturer's specification for each of these sprinklers, and it would be indicated with the information for each of the sprinklers in the manufacturer's specifications. So this is an iterative process. So you would have been looking at your sprinkler options and considering flow and that sort of thing as you went through the process of laying out the heads. So at this point in the process, what you see here are all of the heads laid out, and they're labeled with flow. The next thing that you're going to do is group the sprinklers by their flow or by their precipitation rates. And then finally you can kind of circle them on the plan so you have a rough idea of where your zones are, which will be important because that's going to be part of the way that you determine where you place valves. Now, some factors to consider when zoning include the system flow limitations, the physical dimensions of the area, and then you're also going to want to separate areas by plant material. For example, you wouldn't want to have a turf area irrigated on the same zone as a shrub bed because it's likely they have very different water requirements. So you're going to want to separate zones by plant material. You're going to want to separate zones by precipitation rate and sprinkler type. And what those two things get at are the fact that different types of sprinklers have very, very different precipitation rates. Namely, spray heads and rotors have very, very different precipitation rates. And like I mentioned in the last lecture, rotors tend to have about half the precipitation rate of spray heads. So that's going to be really important to keep those separate. You can also separate areas out into zones by microclimate. So this would allow you to consider whether the area is sunny, whether the area is shady, is it getting a lot of reflected heat, so on, things like that. And then finally, you'd want to zone sloped areas separately because you're going to need to schedule irrigation on those areas differently than you would flat areas. And so you want to be able to do that easily, and one of the ways to do that effectively is to separate them into their own zone. Alright, so a couple of other things to keep in mind. Like I mentioned, you don't want to mix heads, spray heads and rotor heads, simply for the fact that they've got very different precipitation rates. You also want to keep in mind that the application rate should be the same for each head on a given zone or circuit. And you want to apply the principles of a matched precipitation rate. So what exactly does that involve? You want to group, okay, there are a couple of different ways to group sprinklers. Most often, you're going to be using matched precipitation rate heads, and those, of course, you would group together. In this case, you would choose matched precipitation rate heads and then total the flow, or gallons per minute, of each of those. And then that total flow should be less than the maximum safe flow in the area. And you would continue to do that. So if that total was less than the maximum safe flow, that could comprise one zone. You could continue to add sprinklers until you approach that maximum safe flow. It just depends on your approach to the problem. You'd want to continue doing this, so grouping heads of matched precipitation rate until all the heads are grouped. And then that number of groups is essentially the number of valves you need and the number of zones that you have for the particular project. Now here you see an example of a very, very simple zone layout. Here's the valve here. This line indicates the main line. And then you have laterals coming up here and here. And so in this case, what you see are 4 quarter circle heads, 1, 2, 3, 4, and 2 half circle heads, 1, 2. All of these heads are being operated by this valve. When this valve opens, all of these heads are in operation. Now notice the flow for each of these is different depending on the arc of throw. So for these quarter circle heads, the flow is 2 gallons per minute. For these half circle heads, it's 4 gallons per minute. And the reason for that is that you want these half circle heads to be able to apply the same amount of water in this area as these quarter circle heads are. So in order to do that, they've got to be able to put 2 GPM down here and 2 GPM down here when they're running. So they would need a total of 4 GPM. And in this way, the precipitation rate is matched in these different areas of overlap. Okay. Now, it's not always the case that you have matched precipitation rate heads. You might also have non-matched precipitation rate heads, in which case you have to group them based on the arc of their throw. And then what you do is you group heads with the same arc of throw and the same flow. So for example, similar kind of situation, but in this case, these quarter circle heads are putting out 4 GPM, just like the half circle heads. And so if you wanted to apply the same amount of water in these overlap areas over a period of time, you would need to operate these different areas separately. So in this case, the quarter circles are all on one valve, and the half circles are all on another valve. Okay? And in that way, you could run the 2 different valves for different periods of time and achieve the same application rate or precipitation rate in the areas of overlap. So it can be done. It certainly can be done, but you can see that in this case you have to have an additional valve, which you try to avoid that for the simple reason that the fewer valves you have, the less expensive it's going to be, the less maintenance and troubleshooting and so on. All right, now back to our example. So in this case, the heads have been labeled with flow. And so the next step is to group them by flow or precipitation rate. And the way that they have approached this particular design is to create 10 different zones based on a number of factors, whether they were using rotor heads, whether they were using fixed spray heads, whether they were using shrub sprays, but you can see that they have created 10 zones, or are thinking of creating 10 zones, maybe I'll put it that way, and that what they have done is consider all of the heads in each of the zones that they're considering and totaled the flow for each of those zones. So in zone 1, there are 12-foot turf sprays, and the total flow required for them is 19.2 gallons per minute. Oops, sorry. And you can see as you go through these different zones that they have set up, they range anywhere from a low of about 5.6 GPM, which are various turf sprays, I'll point those out on the next image, to that high of about 19.2 GPM. And so a wide variety there in terms of flow rate. So once that has been considered, then the next step would be, oh, I did want to just point out that here is that area with various turf sprays with the very low flow rate. So if you recall back to the selecting and laying out heads lecture, I did point out this area, and I said that even though it was part of this larger turf area, it was an odd shape, and so a few small spray heads might be chosen and selected to cover that area. Alright, so all of those zones have been considered, their flows have been totaled, and the next step is to circle the areas that are going to comprise each zone. Now in this case, something else that must be considered is the total flow that's available for the particular plan. And in this case, the total flow, I don't believe I mentioned this, but let's just say, for example, the total flow available had been 20 GPM. If we go back to our list of zones, you can notice that in none of these cases does the flow exceed 20 GPM. And so that's part of the process as well. And so they've ended up with these different zones. They're lightly circled on the plan, and the total flow for each of those zones is listed. All right, so that's the end of our conversation on zoning. Again, you do have an assignment related to this, so hopefully the information has been helpful.